Assembly today will be even louder than that, so we had it cranked pretty nicely. Worth watching, Ashley? 2.
Wait.
Huh? What? No, I'm gonna go over this homework real quick. But just put it out there. You know, you gotta figure that I love doing that. I absolutely love it. It's one of my favorite things. Other than teaching you guys, it's one of my favorite things to do as far as school goes. Just being involved, doing that kind of stuff. It's good. It's healthy. And who would have thought that you would have had, let's see, 1 assistant principal on drums, 1 dean on electric guitar, 1 orchestra teacher on trumpet, a math teacher on sax, another math teacher on bass, 2 other math teachers, lead singing and backup singing. It's not a whole lot of schools that happens at. When I had done that at Chaparral, I had students, because there wasn't any teacher that had the guts to do it. I come here and they're like, yeah, let's do it. And I'm like, yeah. So, love it. Let's run through the homework. How did it go? It looked like, again, you all had some beautiful graphs, and I love that. And I want to do problem number 1 kind of all together with 1, 2, and 3. Is that okay? Whoops. That's not what I want. I want this. Yes, ma'am.
When does this class end?
When the bell rings? I don't know. I haven't looked. I don't know. I'm sorry. I wish I knew, Mac. I'm going to go until the bell rings, and then we'll call good. I apologize. So, you guys know better than me. You guys always figure this out better than I do.
Class ends at 46.
Okay, what time is it now?
30.
48. Okay, I want to grab these 3 on the same XY axis. Is that okay? So let me go insert. I'm going to insert a graph. Cartesian. Next. -10, +10. Looks good. Yeah, baby. All right. Let's move this. All right. So let's do the first one. We'll do it first one in blue. I know that this has a y-axis or a vertex there. It's going to grow right 1, up 1, left 1, up 1. From there, I'm going to go right 1, up 3, left 1, up 3. That's what our first graph looks like. With me so far? Okay, and I realize I didn't go through all the steps, but we've gone through the steps before. The second one I'll graph in red. Okay? So this one, notice that this kind of moved the whole thing down. Agree? This one is actually going to move the whole thing left. Remember how I said your vertex is opposite inside, comma, same outside? Opposite inside means it's going to make a shift to the left. So this vertex is going to happen here at -2. Okay? It's always opposite. When it's inside parentheses, no matter what kind of equation you're doing, means it's going to shift it to the opposite of direction you would think. The outside number, the add or subtract, is going to do exactly what you would think. So inside, because this one's positive, means it's going to move it over to the negative. With that said, this one should move which way? Just if I was looking at the x minus 3. If this one shifted it left 2, what should this one do? Shift it right 3. It's opposite of what's inside. So on this one, I'm doing this. I still have a lead coefficient of 1. So I'm going to go right 1, up 1. From there, I'm going to 1, 1, 2, 3, 3. So that's what the second one did. So it did a shift to the left. The first one did a shift down. The second one did a shift left. Now the third one is going to shift to the right, and it's also going to shift up. Does that make sense how I said that? So if I look at this one, I'm going to shift right 3, up 2. So right 3, up 2. I still have a lead of 1, so it's the 1, 3, 5. And it looks like that. So your parent function, if if I had graphed y equals x squared, this is the parent function, meaning it's the most basic function of a parabola, would do this. So notice the purple versus the red. The purple to the red had a shift to the left. The purple to the blue had a shift down. The purple to the green had a shift right and up. And all I did is I found the vertex and then I pattern graphed off of it. Seem okay? That kind of looks pretty. So, and again, when I was walking around looking at you guys' stuff, I was like, oh, cool. So, let's take a look at number 4, 5, and 6, and I'll do all three of those on the same graph as well. Is that okay? All right, so what I'm going to do is in purple, I'm just going to do the parent function first. Okay, because I want you to start seeing this. So again, the pattern function, 0, 0, right one up 1, left one up 1, right one up 3, left one up 3. And again, I'm just graphing the parent function so we can see this is the most basic of basic parabolas. Okay, so number 4, we'll do in red. So I get y is equal to x minus 4 quantity squared minus 5. What do you think this one's going to shift, right or left? To the right. It's opposite inside, okay? So it's going to shift right how many? 4. It's going to do what else with the minus 5? Shift down, okay? So this point right here, the vertex, is going to shift to the right, 4, and it's going to shift down 5. It's always opposite of what you think inside, same outside. So this is going to go 1, 2, 3, 4, and then down 5. The lead coefficient is still 1 out front, so it's going to have the same growth. Look like the same parabola that just moved? Yeah. For the most part? If I look at number 5, which way will it shift? It'll shift to the left. How many? 1. Remember, it's opposite inside. What does the 3 do out front? It doesn't move it up 3. It stretches it. It holds the vertex and it stretches it up. Triple. So it doesn't grow at 1, 3, 5. It grows at 3, 9, 15. Okay? So let's first figure out the vertex. So this is the same thing as having plus 0. So I shift left 1. It doesn't move. But then I'm going to go right 1 up 3. Left 1 up 3. From there, I'm going to go 1, 3 up 9. Right 1 up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Maybe up here. And left up 1. What do you notice about the green graph? Other than shifting to the left, what do you notice it as far as the shape goes in reference to the purple? Is it fatter or is it skinnier? Skinnier. So that lead coefficient is stretching everything up. It's letting it grow at a faster rate. If that lead coefficient was a fraction between 0 and 1, this graph would be fatter. The bigger this number gets, the skinnier a parabola gets. It grows quicker. Okay, and then number 6, let's see, we'll do in blue. Number 6, we have y equals negative 2, x minus 3 quantity squared plus 5. Let's figure out the vertex first. Which way will it shift, right or left?
Right.
Right, because inside is always opposite of what you think. And then is it going to shift up or down?
Up.
Up, how many? 5. So I'm going to shift right 3 and up 5. So from the vertex, I'm going to go 1, 2, 3, 1, 2, 3, 4, 5. There's my vertex. What does the negative do to the parabola? Makes it go down. Good, Mac. Makes it upside down. What does the 2 do? There you go. So rather than 1, 3, 5, what's the rate it's going to grow at? -2, -6, -10. Is that right? Does that make sense? So for my vertex, I'm going to go right 1 down 2, left 1 down 2. From there, the next point, I'm going to go right 1 down 6. 1, 3, 4, 5, 6. Left 1 down 6. So the negative flipped it upside down. Does that make sense? Pretty cool? Not that hard, is it? It's a lot quicker than plugging it all in, isn't it? So that's what I really want you to focus on is that pattern graph is a great tool to utilize as long as you have the comprehension to do it, which I know you do. Okay? And then as far as the back page went, they're kind of hard. So we want to see what the equation for each of those would be. So problem number 7, remember I'm going to do this. This is my general form of a parabola. I would say all of these, the A value will be 1. Okay? I don't think we gave you any that have a different growth rate. I don't think. Nope. Okay, the only thing that might change is our A might turn to be a negative if it's upside down. So the first one, what is the vertex of my first parabola? On number 7, what does it look like? Count it. What is it?
3, 1.
3, 1? So this is my H, this is my K. Remember when I plug this back in, it has to make it opposite. This is positive, so it has to have a minus. Remember my A value, I said for the most part will be 1. So I can put the 1 right there, and I can go x minus 3 quantity squared plus 1. There's my parabola. That's my equation. Okay? Now, I saw Steve was like a rock star on this yesterday. I walked over and I was like, yeah. He was like making sure the A value was 1. I loved it. So good job. Okay? Problem number 8, same thing. We're going to use the same equation up there. What does my vertex appear to be on that one? -3 what?
4.
-3 comma 4. It goes upside down. So what do you know about the A value? Negative. And again, I'm pretty sure we're going to keep that being 1 for right now. So I have y equals -1 or just negative x, but that's a minus. So what does this have to be? Positive. There's my vertex, or that's my parabola equation. Okay, number 9. What does it look like the vertex is? -4, -1. Opens up, so I'm pretty sure my A value is going to be 1. So I'm going to go y equals 1. I don't really have to put it there, but it's okay. What is this going to be? X. Plus 4. It's opposite, remember? Always opposite inside. And then -1. There it is. And then number 10, my A value is going to be -1. What does my vertex appear to be? I think it's 3, 7. Is that okay? And it's got to be a -1 because it opens upside down. So I get y equals -1 or just negative. X minus 3. It's opposite. There it is. How do you feel? Seem okay? So guys and girls, I would like you to work on, for your assignment, we have some time still, page 65 and page 66. Now guys and girls, if you are transferring this using your calculator to see the picture, that's awesome. But just realize, I want you to realize you have to find more points, okay? If you just draw what your calculator looks like, realize you have to use that growth pattern from the vertex. I know you can do it. So, quick question while you're starting this. Who is coming to the assembly today? Raise your hand. Oh, yeah. Rush the stage, man.
Rush the stage.
Yeah, show those seniors up. You're like, woohoo! You're like, man, what are those freshmen doing? And juniors. Sorry.
Parabolas